Hi everyone. Today I'll be explaining my sampling distribution model and my statistics that I got in order to create it. So I basically got the proportion of students in my classes that wear glasses. So you may see it's like a large amount of students that I used for my sample size, but this was only to ensure that my success slash failure condition was met so I could find my confidence interval. So I decided to get students from many classes, but I did not reuse students, if that makes sense. Like each student is their own person. So 80 students from my classes have been randomly selected. This was my proportion, so 0.13% of them wear glasses. So for the plausible independence condition, I do think it's reasonable that the randomly selected students are independent just because that one student wears glasses is not changed by the fact that another student might wear glasses or does not wear glasses. Same thing goes for the randomization condition. Um, the students can be assumed to be chosen at random because they are chosen at random. And for the 10% condition, 80% is less than 10% of the population of all students. Now, even though Tinian High School is pretty small, I'm thinking of the population of all the students who have possibly gone to my school. So that's how I believe that 80 is less than 10% of the population of all students as a whole. Um, for the success slash failure condition, this was what I emphasized in the beginning, what I wanted to make sure I met. So there are at least 10 successes and 10 failures. You can see that um, that 80 students multiplied by my P is 10.4, which is greater than or equal to 10. Same thing goes for my Q value. It's greater than or equal to 10. And since all of these assumptions were met, that's how I knew I could find my confidence interval. So the process or mechanics that went into finding my confidence interval. First things first, I wanted to make sure I found my standard deviation. So here's the formula right over here. So the square root of PQ times Q hat, P hat times Q hat over N. And so this is what it looked like, 0.13 times 0.87 over 80 equals 0.038, which is basically my standard deviation. Next things is to find my z-score or my z-value. It was a 95% confidence interval, which is 0.975 in order to find your z-value. So that would be 1.96. So next, you would need to find your margin of error. So I used the z-value and multiplied it with my standard deviation in order to find the margin of error. And then once you find that, you subtract it and add it with your 0.13 or the percentage of students who wear glasses or my p-value. So the lower confidence interval limit, so that was 0.13 minus 0.074, which is 0.056, and the upper confidence limit would be 0.204. Now, 95% confidence interval is 0.056 and 0.204. In other words, 5.6% and 20.4%. So next for my interpretation. So I'm 95% confident that the intervals contain the true proportion of students who wear glasses, and about 95% of random sample size 80 will produce confidence intervals that contain the true proportion of students who wear glasses. And last but not least, my model. So this is basically how it looks, 0.13 right in the middle, and then the standard deviation added onto each next number, which is 0.038. So that's how I got these numbers. And then subtracted with the standard deviation over here. That's how I got these numbers. Then I labeled it 68%, 95%, 99.7%. And then the shaded region right here is basically my 95% confidence interval. So that's that. No, thank you guys. Bye.